We start chapter 4 by looking at what we know about different types of data. Quantitative data are numbers that could be either discrete counted numbers or continuous measured numbers. Qualitative or categorical data are words that could be nominal or ordinal words. Ordinal means there's a definite order or rank in the words. We often prefer working with group data because it's easier to manage large numbers of scores. We do lose detail of individual scores, have to make sure the groups are the same size with no overlap between groups and no gaps between groups. When working with a frequency distribution table for group data, we need to include a class center column. We calculate this class center by adding the lower and the upper boundary of the class and then divide the answer by 2. And we do that for every row. 20 plus 29 is 49, divided by 2 is 24.5. Continue that for the rest of the table. We add the tallies to get the frequency for each row and also add the total of the frequency column. When we are asked to do a cumulative frequency histogram and or ogive, or asked the estimate for the median or the quartiles, we need to add a cumulative frequency column. Cumulative frequency is just the running total of the frequencies. So the first cumulative frequency will always be exactly the same as the first frequency. We then use this first cumulative frequency added to the next frequency. 7 plus 6 is 13. To find the next cumulative frequency, it's 13 plus the next frequency is 21. 21 plus the last frequency of 4 is 25. This last cumulative frequency and the total of the frequency column should always be exactly the same. When you are asked to calculate the mean, you need an fx column with your frequency distribution table. That's just the frequency times the class center for each row, and you just continue doing that for every row of your table, and you add the total for this column that will assist you in calculating the mean. When we do histograms and polygons, we need to work as accurately and neatly as possible so that we can get accurate readings from that. Start with an appropriate scale, label the scales, and then add the histogram with no gaps between the columns and half a unit gap at the beginning. You overlay the polygon over the histogram with dots in the middle of each column and the polygon joining the axis half a unit at the end and half a unit at the start. So it starts at the bottom and it goes down to the bottom again. When you are asked to do a cumulative frequency histogram and ogive, you use the numbers from the cumulative frequency column in the frequency distribution table. And you now join the dots in the top right-hand corner of each column, and the line of the ogive does not go down at the end. We use the cumulative frequency histogram specifically to find estimates for the median, upper quartile and lower quartile. We've got a total of 800 scores here, so the middle position would be 400. You draw a line until it meets the ogive, go down and find the value from the horizontal axis. Lower quartile is the middle of the lower half of scores, so that would be score number 200. Once again, draw the line until you meet the ogive and then go down to find that value. And quartile 3, or the upper quartile, is the middle of the upper half of scores. So score number 600 is halfway between 400 and 800. Draw the line until it meets the ogive, go down to read the estimate for the upper quartile. Measures of location or measures of central tendency refer to the mean and the mode and the median. The mean is just the average of scores. Add all the scores divided by how many scores you have. The mode is the score that occurs most often or the score with the highest frequency. And the median is the score in the middle position of the sorted scores. We have to be able to find measures of location and measures of central tendency, whether the scores are given to us in a list, in a frequency distribution table, in a stem and leaf plot, or in a dot plot. And we are now going to look at examples from these different presentation methods. This list of scores have already been sorted, so that makes it less work for us. If we have to calculate the mean, we just add all the scores. We've got 8 scores there, so we divide the total of the scores by 8, which gives 14.125. In an exam or test, you always have to read carefully what rounding is expected and then round your answer appropriately. If it's not specified, rather give more accurate detail than to round and lose some of your accuracy. The mode. The score 15 appeared more than any of the other scores. That's why 15 is the mode. You can also have 2 modes in a set of data. That's then called bimodal. You can have more than 1 or 2 modes, or you can have no mode, where none of the scores appear more than any of the others. To determine the median works slightly differently when you have an odd number of scores and when you have an even number of scores. If you have an odd number of scores, we always first determine the position of the median. In this list of scores, we've got 9 scores. So 9 plus 1 is 10 divided by 2, shows us the median is in position number 5. The score in position number 5 is 15, so the median is 15. If we have an even number of scores, we determine the position of the score in the same way. 8 plus 1 is 9, divided by 2 is 4.5. So the median will be the scores on either side of position 4.5. So score number 4 plus score number 5 divided by 2 gives us 14.5. Determine measures of location from a frequency distribution table. The highest frequency is 10, so scores in the class 3 to 5 appeared the most often. So the modal class is 3 to 5. To calculate the mean, we add a class center column and an F times X column. The class center, we add the lower and the upper limits of the class, 0 plus 2, and then divide the answer by 2 is 1. F times X is the class center times the frequency, 4 times 10 is 40. The total of the frequencies, how many scores did we have? And the total of F times X is the total of all the scores. The total of all the scores divided by how many scores? 86 divided by 20 gives us a mean of 4.3. You need to add the cumulative frequency column to the frequency distribution table and draw a cumulative frequency histogram and ogive if you want to determine the median. This cumulative frequency histogram lacks the half a gap in the beginning. We join the top right-hand corner of the columns to give us the ogive, and now we are going to determine the median. We see there's a total of 20 scores. So the middle of 20 scores would be score number 10. We draw the line until it meets the ogive, and go down to make an estimate for the median would be just below 4, 3.8 S. And there would be some leeway for estimation there, but it's clearly more than 3.5 and it's clearly slightly less than 4. If we have to determine the measures of location from a stem and leaf plot, once again the mean is, remember that the stem plus the leaf forms the number, so we add all the scores, divide by 10 scores gives us a mean of 30. The mode, the score 12 appeared twice and none of the other scores appeared twice, so 12 is the only mode we have here. The median, we have 10 scores, so the median is the average of score number 5 and score number 6, so it would be 28 and 38. Divided by 2, median would be 33.